Captain Chaudhari in my series of videos on marine astronomical navigation. Today I am going to talk about circumpolar body. In a school geography we read that if we go to north of Norway, etc., in summers we find the sun does not set. It's called land of midnight sun, etc. But circumpolar body, the knowledge of circumpolar body should not be limited to the sun being viewed throughout the day, right? It is something more than that. Any heavenly body, any star can be circumpolar provided it follows certain conditions. What are those conditions? In a latitude, in a given latitude, if the declination of the body is of same name and total is more than or equal to 90, we say that body will not rise or set, it will remain above the horizon. Now when the earth spins and we feel that all the heavenly bodies are going from east to west, at the same time these bodies also, while they maintain the same angular distance from equinoctial, they also maintain the same angular distance with respect to pole. Or we may say that these heavenly bodies, depending on what is their polar distance, they maintain same distance with celestial pole and they go around the pole. So what happens if we have a situation where the latitude plus declination of a heavenly body is more than or equal to 90 degrees. So that heavenly body, while doing the normal meridian passage, that's from east to west, apparently it goes from east to west, is at upper meridian passage, and after half a sidereal day, the same body appears to go from west to east, crossing the lower meridian. Now this meridian from the north celestial pole till the horizon can be considered as the inferior meridian or the lower meridian. Now the condition that is satisfied by this particular star, if we consider that this is declination and we say this is the latitude, appears that latitude is also north and declination is also north. Let us say that the latitude is 40 degrees north and let's say that the declination is 65 degrees north. The total is 105 degrees north. There is this altitude at the lower meridian passage. It is called lower meridian altitude. This part is the polar distance. Even this part is the polar distance. And as I said, this part is declination and this is latitude. From here to here, if you say is the latitude, can we say that the lower meridian altitude is equal to latitude minus polar distance, and polar distance is 90 minus declination. So can we say it is equal to latitude plus declination minus 90, right? So we have this golden rule, golden formula, that whenever you see a lower meridian passage, you can always say that lower meridian altitude is equal to L plus D minus 90, right? The lower meridian altitude is L plus D minus 90. It would be interesting to compare the lower meridian passage and upper meridian passage. Let's look at that. Comparing the upper meridian passage and lower meridian passage, at upper meridian passage the body appears to go from east to west, whereas at lower meridian passage we can say that body appears to go from west of meridian to east of observer's meridian, right? So this east and west is referred to with respect to the observer's meridian, right? Upper meridian passage is crossing of observer's upper meridian or observer's celestial meridian, and lower meridian is crossing of observer's lower meridian. At upper meridian passage, the true zenith distance is least, and at the lower meridian passage, the true zenith distance is maximum. We can say at upper meridian passage the azimuth is north or south. Same here, azimuth is north or south. At upper meridian passage the LHA of the body is 0. At lower meridian passage the LHA of the body is 180 degrees. The meridian passage which is closer to observer's zenith is the upper meridian passage, and the meridian passage closer to observer's rational horizon is the lower meridian passage. So this is how we can compare the upper meridian passage and lower meridian passage. At upper meridian passage the meridian zenith distance is equal to L difference D, same name subtract, different name add. Whereas at lower meridian passage the lower meridian altitude is equal to L plus D minus 90. So this is how we can compare the upper meridian passage and lower meridian passage. Let's do a few numerical to understand the process of upper and lower meridian passage. So let's say we have a latitude of 40 degrees north and declination of the star 65 degrees north, and we can see that L plus D is more than or equal to 90. So we cannot find out the rising and setting amplitude because the body does not rise or set. Okay, coming back to the diagram, when we know that the body is circumpolar, so instead of worrying about the declination that is 65, we find out what is the polar distance. Polar distance is equal to 25 degrees. 90 minus 65. So what we do is we draw a circle, divide it in 4 parts, west, east, and now the latitude of 90 degrees, we divide this in 9 part, and 10, 20, 30, 40, this is the position from where I need to draw the equinoctial. This is WQE, WZ is the prime vertical, and the same distance from here we have the north celestial pole. Now this also can be divided in 4 parts. Even this length represents the observer's latitude like this, ZQ. Okay, now if the polar distance is 25 from the pole, 10, 20, 25 this way, and the same distance downwards, we draw a circle. This is a circle of the polar distance. The star will move on this declination circle, parallel of declination. This is the upper meridian passage. After half the sidereal day, there will be lower meridian passage. Now what is the upper meridian passage zenith distance? So I had said L difference D, same name subtract, different name add. So here it is same name subtract. So L difference D is 25 degrees. So you can see that this distance is 25 degrees. And similarly, if we want to know what is the lower meridian altitude will be L plus D minus 90, that is 40 plus 65, that is 105 minus 90, and that is 15 degrees. Like in another numerical, which is about lower meridian passage and upper meridian passage, it might say that a heavenly body crossed observer's meridian with the azimuth 180 degrees and altitude as 75 degrees, right? So the body is seen on the south of observer. From the observer's zenith, the body was seen in south direction, and after about 12 hours, the body was again seen bearing 0, 0, 0 and altitude as 15 degrees. Find the latitude and declination of the body. Now this is clearly the case of circumpolar body, a body crossing the upper meridian, and then the body is also crossing the lower meridian after some time, and it is seen by the observer. So what we do is we draw a circle, right? This is a celestial sphere in the plane of observer's rational horizon, and what I suggest is whenever latitude and or declination is not given, what you do is place the body according to the altitude and azimuth. The first observation of the star is bearing 180 degrees and 75 degrees from the from the horizon. So I place the star over here, and this is 75 degrees. That means this is 15 degrees. And next, the body was seen bearing 0, 0, 0 and altitude 15 degrees. That means I look at the star over here. This is x and this is x1. This is 15 degrees. Now, if this distance is 15 degrees and this distance is 75 degrees, total distance from north to south is 180 degrees. From 180 degrees, we subtract 15 plus 75. That is 90. So what we get is 90 degrees as the distance between x1 and x2. But exactly between x1 and x2, we have the pole, which means this distance is polar distance. So polar distance is 45 degrees, half of 90. If the polar distance is 45 degrees, we say that the declination is 45 degrees. Now, the north celestial pole is visible. The elevated pole is not south celestial pole. It is north celestial pole, which means that the latitude is north, and because the body is circumpolar, even the declination is north. So we say declination is 45 degrees north. We also have one relationship, that latitude plus declination minus 90 is equal to lower meridian altitude, which is 15 degrees. We know the declination is 45, so latitude should be equal to 45 minus 90, that is latitude minus 45 is equal to 15. So latitude should be equal to 60 degrees, once again north. So if the latitude is 60 degrees north, right, what we do is from here or 30 degrees from here, we mark a point called Q and we draw the equinoctial. So now the body is shown circumpolar this way, you know. This is the upper meridian passage and this is the lower meridian passage. So this is how, by drawing the diagram or using a few formulae, we can find out what is the latitude and declination. Now I want to tell you one interesting and practical thing. You are in northern hemisphere. Have you seen the pole star? The pole star is approximately equal to the latitude of the place above the horizon. So if you see in the north direction on a clear night, you will find a dim star. That is the pole star. Now if this is the horizon and you look at the pole star, this is the lower meridian. So I sometimes ask the students, have you seen your lower meridian, inferior meridian? So this is your inferior meridian from the Polaris down to the horizon. And if you draw a circle with pole star as center, all the stars which fit within this circle are circumpolar stars for your latitude.